What up, AP Stats team? This is Coach Jay, along with Jacqueline and Brianna and Jaden and everybody, all of the AP Stats team today. And Chloe and Kristen and Michael and John Michael and Alex and Chris and Shane. All of us together in harmony. Hey, real quick, I want to get this on the. Did I miss someone? Oh, Sarah. And Sarah. She was sleeping. Okay. So as we look at this, just a heads up as you're writing this, and really for the podcast as well, we got the probabilities, if you remember yesterday, from numbers 1 and 2. And if you remember the idea of what is my hourly wage and what would be the probability of getting that increase that's there. So as we look at this, we know that to get 9, right, we have 0.3. Chris was with me, by the way, just so we know. Okay, so awesome. All right. Some of you are like, we're good. So we start with an hourly wage of 9, right? And then we would say, what's the probability of getting a 9 and plus a 1 increase in hourly wage, right? $1 an hour. So we add those two to get 10, but the probabilities we don't add because that wouldn't really make sense, right? Because if I added 0.3 plus 0.7, that would be like 1, right? So we multiply those together, 0.3 for new distribution, right? When we combine them together. So think about it. I mean, really, if you added them, the probabilities, it would exceed 1, which we know that a good probability distribution adds to 1, right? And all of these are what are these on the top? Someone could tell me that. How do we get the top? Good, Brianna. Yeah, this is all the possible solutions for our hourly wage and then our increase in wage that's there, okay? Y'all good on that? Calculator stuff, talk to me on that. How do y'all feel on the calculator stuff? Ish? Yeah? What are we struggling on? Do you know the L1, L2 stuff?
Let's do it. Can we try?
Yeah, absolutely. Let's take some minute for the calculator to come up. But while it's coming up, this is good to tell you the class is sponsored by Gatorade today. I'm just waiting. I'm sorry. That would be cool, though. Be cool. All right, so we're going to put it in. Remember L1, if you go to stat edit.
Wait,
stat edit.
So we do N and L1 and then all the probabilities in L2.
Correct. So N is all the L1s. The L2 is all of the... So we go to stat. We go to edit. And there we are, right? So we have L1 and L2 in the context of all our problem that we have here. We put them down for the L1, L2. Then we go to stat. We can go to calc on this side. And then the one variable statistics would be L1 would be the list of values, right? And then the frequency, that normally is left blank. Why do we put L2 again? This is just good review. Jane? Do each of the values hold the same probability? No, each of the probabilities is different, right? And so because of that, we've got to kind of put the probability in for the frequency list. Now, when you did that, what'd you get for, does that make sense, by the way? Is everyone good? Gucci? All right, coming back here, what is the mean? What'd you get for that? So this is x plus y, right? That's how I got this chart.
It says error.
That's what you got as error. You might have missed something, maybe missed one of them.
Mean was 13.
13.45, all right? This is big time. You want to get this down. This little section right in here is very, very important, like golden nugget important, all right? So we're headed into that. What is the standard deviation? 2.4. Thanks, Chloe. So we've got 2.4. We've got the mean is 13.45. What would I do to get to variance?
5.76.
Good. We'd square it to get to 5.76. Nice. So we go right here. This is 5.76. Now we're going to give some serious tickets out. In fact, I'm probably going to give right now 6 tickets if you can tell me how I got the new mean. We know we did it through the calculator, but we added 2 distributions, right? An X and a Y, where X was like the hourly wage and the Y was the increase in wage, right? How could I get the new mean? Someone raise their hand and help me. So this was the first one, right? First mean, down yonder. The second mean, we added them together to get what was up on top with the new stuff down below. What did we get, Jaden?
How you got it?
Yeah, how did I get
Like
it?
10 times 0.21 plus 10, like adding all of them together and multiplying by each other.
This is true. It's an expected value, right? So we could just do it the way we normally do. But how did we use, and make this a bad question, when I added them together, x plus y, what could I do with those old ones to get to the new mean when I added them up, other than what Jaden said, which is our traditional expected value method? Look at your old means.
Would you add the two old ones together?
Yeah, Jacqueline's exactly right. Look at the old means, right? If we look back at it, what was this one? 11.85, right? What was this one? 1.60. So it stands to reason, right? If I were to add them up, we would get what? 13.45. So what can we do to get to the new mean? We add the means together. That's pretty good, right? That's not too hard there. So we would say the n is the new one, okay? So we would say the new one would equal the mean of x plus the mean of y. Cool? It's not bad. So if I have two that I add together, guess what? I add them up. Here's the question. What if I subtracted x minus y? If I took away, and I was mean, and I took away $1 an hour or $3 an hour, what would happen to the means? Yeah, you would subtract, right? Exactly, Alex. So means pretty easy. It goes one way or the other. It's pretty simple. Now the new one, here's the deal. Standard deviation is different, okay? Notice, what was the first standard deviation? It was 2.20, right? Hold on tight just for a second. What about this one? 0.9, right? If I added those together, they would equal what? We're headed there, not multiplying. But it would equal like 3.1, right? Which is not equal to what I found here, 2.4. So I need you to join our team. This is like our chant. All right, ready? If we ever break it out, this is what we'll break it out on. All right, hold this up. All right, right here. I want you to recite after me to join the team. Here we go. One does not simply add standard deviations. All right, very good. You did, and that's why. You rock. You rock. All right, here we go again. Raise it. All right, put it down. Now raise it up again. All right, here we go. One does not simply add standard deviations. If you add standard deviations, I will haunt you in your sleep. Do not do it, okay? You can't do it. So when we add x and y together, mean is the easy way. Just easy. Standard deviations is tougher, okay? So here we go. You just got to know this. It's the square root.
You wrote a long one too.
Y'all whine for a square root. There we go. Square root of the standard deviation of x squared plus the standard deviation of y squared. Now, I'm not going to go into the logistics of why that's true. Just if you think back about like standard deviation, how we found standard deviation, it probably would make a little bit of sense because you've got positive and negative values, and we could go into those logistics. I'm not going into that. We just know that if we add them, this would be the formula that we would find to get to 2.4, okay? All right? Because why? Why can't we do it? Because we cannot, one cannot, simply add standard deviations. Cool. Very good. With our gang sign, all right? Questions on that? All right, rockin'. Let's do this. My favorite part of the lesson is?
Golden
Nugget. Golden Nugget. Oh, it's my favorite. It absolutely is my favorite. I love. How many of you actually get excited about the Golden Nugget? I see all those hands around the room. This is so beautiful. John Michael, you smile when it happens. It's just great. That's exactly right. That's exactly it. There you are. All right, let's talk about this. Adding and subtracting. This is really the important part. You've already gotten this down. When we add, this is what we get on this side for mean and standard deviation. So this would be like x plus y, where x and y are random variables. Okay? And then over here on this right side, this is where we subtract x minus y. And that's where we subtract random variables. Okay? What do you notice about, well, the means are pretty easy, right? Whatever you do, that's what we do, either add or subtract. But what do you notice about the standard deviation? Yeah, good, John Michael. It's the same thing regardless, right? So whether we add or subtract two random variables, we will always use the same formula because one cannot simply add standard deviations. Nicely done. Good. Okay. Awesome. When we hit a big 3 in a game, I'll hold this up, and everybody will know in the stands that they think it's a 3, but we know. All of us know. One cannot simply add standard deviations. Good. All right, so square them, add them together, take the square root. As you're writing this down, I want to make sense on the green side real quick, because this can be kind of complicated, and then I'm going to have you kind of engage together on something that's there. This right here, if I had a normal distribution, the same applies, okay? So if I had a normal distribution for x and a normal distribution for y, and I were to add those two together, in that context, what would I do with the means to get my result? Same idea. I would add the means together to get my new mean, right? And that's how I would actually put the new mean right here by adding them together. But then the standard deviation, you've got to be careful that you don't just add those up, okay? I've seen this a lot on an AP exam because, again, what do we go to? We have to go straight to this formula to find the new standard deviation. When we combine two normal distributions, that's here, okay? Cool. Cool. And that's how we would attack it. All right, questions on any of this behind me? Y'all feel okay on this? I know that, Jacqueline, I don't know if that helped you because you had some questions on 6.2 on there. I hope that answered some of them. If you have more questions off the homework as you're engaging on it, let me know, okay? Let me know and we'll be good. Hey, some announcements real quick, and then we're going to go into something that I want you to do. We are going to have stats giving. Yes, I said that right. Stats giving on, though I have y'all Thursday, right? Thursday. If y'all want to, it's not a requirement. The other class actually was like, hey, can we do stats giving? I'm like, I just went with it. So if you want to do this, that's great. You just put your name and what you want to bring, and we're going to it'll actually be a great day. Thursday will be a fun day there. We do have a quiz on Thursday, so a reminder on that. And then 6.2 is also due Thursday as well, in class, okay? In class. Unless you have some outside questions, which I will be here Thursday morning for if you want to, okay? But y'all want to do that? I don't know if that's something you want. If you want to, put your name down, what you're going to bring, and we'll go from there. Other than that, I think that's it for announcements. Y'all questions on stuff coming up? You may. Let me get started on this, and we'll be good. Before Michael heads out, here's what I want you to do. If you and your group can get all 3 questions right here, here, and here, okay? I've got 6 tickets for each person in your group if you can get all 3 correct, okay? So this is a good check your understanding. It's a very important question on the test and the AP exam, but I want you to try numbers 1 through 3 related with the check your understanding, okay? Ready? Go. Let's do it. Break. Let's go. I'm also going to give y'all a Starburst. Don't open it yet. We're going to use them in a second, okay? What's that? No, you're just borrowing it for a second, okay? But just don't open it yet, because we're going to use it. No, it smells so good.
I hope I got one. But that's really salty.
Use my time.
I hope I got one.
Oh, gotcha.
$6 one.
Guess what you think is in there. I was gonna guess. Okay, I think one. I think one pink, one orange.
Oh no, I was laying on the ground with sausage. Trader
I love
said,
orange.
I think they put something in my sauce.
Pink, and then orange, and then yellow.
Yellow?
Is
It's
yellow
not
your
yellow,
favorite?
I did this to myself.
Oh, you suck.
Here you go. We're going to
No, you have to have
hold
one.
on to those.
You
We'll
put
get
them
them
together.
in a second.
What's your favorite? Pink.
Okay, everyone's favorite.
Yeah, and then it's orange. Yes, and then it's yellow. Red is just.
Easy one.
No, it's not.
Coach Shay, what's your favorite color? Like it's
Oh, that? Oh, you'll hear me in just a second. Talk about it.
The order is pink, orange.
All right, you got 6 minutes.
you just had to meet.
If you could answer with the interpretation, that'd be great. So what I mean by that is, I don't have to restate the question in context. Just tell me what mean would be. So if I did this many, many times, that whatever value you would find would approach that.
If you didn't have them, you know, for example, then you'd have to find the means separately and then just add it together.
University of Tucson.
But
Oh, yeah, you could have gone.
Oh, then that was okay.
No, I made some.
Alright, we're giving you about 6 more minutes here. Get that down.
Wait, what is
It's X plus Y.
Again, if you could at least write a little in context, that would help with where we're going.
Like for me, would we say like the average?
I think it's just the two main types.
Yeah, so with this, the average, the expected value would be like, if I pulled a random day many times, and just like a random one, that it would approach my expected value.
Oh, okay. So when dealing with like the amount of cars sold, it wants to know
Yeah,
the
exactly. So the amount of
standard deviation of
ones
T.
leased, cars sold and the cars leased combined, yeah, that would be good to say as well.
No.
Brianna just said for the second one, she was like, do we just have to add the standard deviations
No.
together? She literally just asked me that.
I'm really sorry.
Oh no.
No, you have to do the square root thingy that we just
They
did.
didn't bring me a turkey for Friendsgiving. Wait, what?
It is Thanksgiving. I don't know. I'm going to try to find a turkey. I'm going
Cool.
hunting first.
Alright, get it down. Here we go. Hold up, did you really?
Did you get it?
What has that had?
But I think
How does one find it?
if we rounded to the 10.
That's perfect. Usually, I would actually go to the second decimal, just because
Yeah, the 10.
that's the hundreds.
Oh.
Yeah.
Well then,
Which one's
You good? You good? Yeah, the first one's the 10th, the second's the
Oh, okay.
hundreds. It's a little funky, I know.
we have to put in.
That's still
You technically do add them. Because it's like,
I don't get it.
Find the mean and the standard deviation to margins total. I got those.
I guess it's just add.
Wait, I'm confused.
Yes, ma'am.
I don't understand the formula and like how to plug it in.
What?
Find the mean and standard.
So we would take each of the standard deviations and square. Really, what is squaring? What are we doing? We're finding the variance by squaring both of them, right? We can add the variances together and then take the square root to find the new standard deviation.
So Brianna, you just did 0.6
So to find u to the mean of
0.43 and
the
squared it.
mean of t.
No, we
just add
squared
the
each
mean of
separately.
these.
So I find the variance of
And
each
then for
here and
this
here,
one, you would add the.
and then by squaring them, add them together, then take the square
The
root.
square root
So you
of
squared
of the standard
0.943
deviation.
Yes.
and then you squared 0.64.
That's the variance.
And
Sorry,
you added
variance.
Yes.
So the
Thank you.
variance of this
Why
and
do you
this,
have
so
to
you just
square
like square it.
Because it's not the same. Like if you
And then
take the
you
square root of
add it.
this
No,
plus
we're just
this square plus
I
this square,
assume he
the
gets
square root doesn't go over. Does not apply to both of them.
How would you?
Does that make sense? Because they're not being added up.
You would put in parentheses and then you would take the whole square root. And then you maybe it's like
I think you got it right. 1 point.
we should try it.
Please
That was wrong because I used the standard deviation.
I saw 1.3, but yeah, I think that's right. That's right. I got it.
Oh yeah, because I was looking at the answer.
Coach
Yeah,
Jay,
it's good.
Yeah,
Yes, sir.
can I write down the context or can I just say it?
That's fine if you say it too. Just on the AP exam.
Right.
Don't just say.
Why are you being racist?
So
Yeah, you are. I'm part turkey. Is
Those are the
there a problem with that? Do turkey lives not matter?
of all cars.
Yeah, so we kind of have 2 things going on, right? So it's
I mean,
it's really the total bonus from this and this. But
Wait, wait.
for
So
every
everything increases. So
Yeah.
why
Yeah.
is it so once x increases by 5, it's not
and for every
because why is each car
Yeah.
used in hundreds
so what
You
so
seem
what
dark.
we do
I
is
see that like in the, so it says y is the number of cars leased, it's 300 bonus for each car
Everything
leased.
dark is
So then we multiply everything by 300.
So then I
Yeah.
got these
Just
two
tell me
numbers
add.
that I turned from cars.
Bro,
to
Audrey is
like
so
for
old.
Do
money
you see that or
value.
not?
That's
Would
the
you add
expected
Riley?
amount that I would get in money and
Your best friend.
Yeah, which is increased by 500 because everything you would
The question
just
is,
add
what
by
do I
500 for
mean?
x.
And what's
I don't
the-
know.
So then-
They have different. We have different kinds of friendships.
So 500 times.
So who's number one?
Am I making sense on that?
I don't know.
I feel like it's Coach Jay.
Yeah, Coach Jay's my number.
So it's definitely Audrey. But like,
Combining
I see like
what we
you're
did today
Audrey
and what we did today.
That's true, but me and Audrey live in the
Because we're
same
kinda
neighborhood, so it's
multiplying
really
and
easy
seeing-
for us to hang out. And
Does multiplication affect the mean?
Standard
Does it
deviation
affect
is the same, but they would say like the same.
And then
like,
also combining them together once you've done that.
Lindsay's getting her ear.
Wait, where did
All right, keep going. Stay focused. Stay focused, y'all. Number 3.
Wait, what?
Make sure we write a little context and work.
So what?
Just for that for a piece that.
So we just have to read that.
No, for the meat, I think you should add the 500, would you not? Yeah, so 500 1 is 300. Point seven. Where did you get?
Oh wait, Alex is right after.
But it's 0.7.
Total bonus. So you add the two digits together to find the total bonus.
I was just like talking like.
Oh, total.
And then put them in the formula. Cool, okay. So.
You multiply
This
first.
is not
Where did you get the?
Chris, how we doing?
That's like.
Good on it?
Because it's
from tribe. I was a long tribe.
Multiply or
I'm
add?
telling you, if you say it again, I'm going to know.
To the what again? I'm sorry.
For 3.
So for the mean, are we talking about?
We added like 500 to like the meat and 300 to the meat.
So did you multiply 500 times 1.1? You added 500. So I would.
Can we multiply?
So this is cars, expected cars I sold on a given day, right? Expected cars I leased on a given day. $500 is what I get per car I sell, right? Bonus. So I would multiply the 1.1 times the 500. Same thing with lease. Does that make sense?
Yes.
So you're kind of converting it to dollars and cents.
And then the other one's 210.
All right, I'll give you about 2 more minutes, okay? 2 more minutes. Make sure that you put a little bit of context there, or in this case, really work shown is really what I'm looking for there, okay?
What was the standard deviation?
What time I get?
Stay the same.
Questions now.
What time I'm gonna go outside?
Okay, so not necessarily, because if I multiply, does it affect it?
60.
It would, right? And then once I take those and multiply them, then I have to add them together, right? Right? So when I add them together, we're going to plug it into the formula we just did, right? So you're kind of doing 2 things, right? Multiplying and then plugging it into the formula. Does that make sense?
Just kidding.
So standard
You multiply
deviation.
500 times 1.5 and
We'll
divide by
change it, yeah.
12.7 and then you add them together.
Does that not make sense?
I don't know how to do it.
So just like you did does it make sense the expected amount that you just solved for? Y'all rock that.
Do we multiply it by the original standard deviation?
Yeah, so now we've got to convert these 2 amounts of money too. So that's why I would say 500 times 0.943 and 250. Stay focused, y'all. Make sure we're still in it. If you're done, just hold off just for a second. Okay?
300.
And so this is the amount of money for my standard deviation, right? And then what are we going to do once we found the total money?
We add it.
That's when we add them. Good. All right, hey, check real quick.
Find the
See.
total bonus.
Oh, hold up just for a second.
You don't add standard deviation.
The 300
Well, he
for
wants to know
what?
the standard deviation of the manager's total bonus. So then you have to add.
Read real quick.
Oh, wait, no, sorry, not adding,
What
you
does that
read
go
the
to? $300 bonus for, what represents car leased up here? Right? So when you do 500 times 0.7, it would be 300 times 0.7. Kristen, y'all good over there? Chloe, y'all okay?
Oh my god, I'm going to literally.
You need the number. Okay, so for eggs it's 471.5,
Good. One thing I see about standard deviation.
and then y is 192.
It is because
And then when you put it into the formula, it's 509.09.
We turn out.
I don't remember what the value was, but that sounds right. Good stuff, Chloe. All right, hey, double check real quick. Let's see if you got these right. Check the answers. Okay, so as I look at this, no, mine is too. I hate it. As I look at this, a couple of things you need to note, okay? Now, John Michael had asked me, hey, do I have to put context for this? In this setting right now, just because we were trying to solve it and get that down, I'm fine with you not doing it, but you've got to hear me out and understand that work shown is huge, and then also stating, if it's especially on an FRQ, over many Fridays, that's the context, the dealer would expect to sell 1.8 leased cars and cars that were bought outright, okay? All right, Jane.
On the last unit, you said that context was like writing down the formula. Does that work for here too, or do we have to do the same thing?
I would say that if I'm talking about expected value or standard deviation, let's interpret that a little bit.
Okay.
You know, especially when it says find and interpret. Like this, I did not interpret that, right? So I think everybody got this, but this would be average distance from the mean, or it typically varies by 1.14 from my mean, right? You could say either of those two. Now, how many of you got 760 down here? By multiplying 500 times 1.1 plus 300 times 0.7. The big thing that I'm noticing is that you know what to do. Sometimes you all have and here's the deal, I have issues too with this. It's not just y'all. But taking what the words are up here and understanding what they're trying to talk about down in part 3. Okay? So I would just say highlight, take your time, go through it. You've got time, especially on those FRQs, to dissect it. Questions on how I got here. By multiplying 500 times my mean, 300 times my 0.7, and then adding those up to get my total of 760, right? And I didn't interpret that. I probably should have. If it was an FRQ, I probably needed to say something else about that, okay? Now, I'm not going to say any names, but I saw some people multiply 500 times 0.943, a couple people actually, and then add 300 times 0.64, okay? Remember, no names. One does not simply add standard deviations, right, Chloe? Okay? Chloe got it right. I was just messing with you. So as we look at this, we're going to square both of them, right? We're going to plug it into the formula. Remember that when we multiply to get it to the actual money value of $500 bonus for each car, which is up here, right? And then for the leased cars, $300 per one. Does multiplication affect standard deviation? Yes, it does. That's why we multiplied, right? That's why we multiplied. Now, Kristen, does adding like a constant value, does that impact the standard deviation? No, right? But you've got to be careful because when I'm adding x plus y, that's different than adding a constant value. That's a good word. Let me say that again. Adding a constant, it's good. Adding a constant value, let's say plus 10 to all of them, does not change the standard deviation. But adding, thank you very much, appreciate it, Brandon. All right, adding put my name on it. Adding two of these together does impact the standard deviation. Am I making sense on that? Brianna?
I just don't understand these words.
Okay.
So like,
Every class.
okay, so like, I don't know how to apply, like you said, what we're, like, because I know what to do.
Okay, what if I said on each of the cars sold and cars leased, we're going to add 1 to each of them. It's during January, it's hot month or whatever. So we add 1 to all of those for our probability. If I added 1, what would change? Would the centers change? Yes. Yes, they would, right? Because they goes like, does standard deviation change? No, because do you see right here? But if I were to multiply all these values by 10, would mean change? Let me backtrack. Not 10. We'll do the example. If I multiplied $500 per car, right? That's multiplying per car. That would change my mean. We multiplied 500 times the mean. And it would also change my standard deviation because when I multiply, multiplication does affect standard deviation. Highlight this one right here. This is a great one for the test. If you just got what I did behind me, you just got what we did today and what we did yesterday. Okay? Does that make sense? Multiplying, adding on a constant versus... okay, so the difference on that is over here, when I add 2 probability models together, do you see the difference?
Okay.
That's different than adding or subtracting a constant.
Oh, okay.
A constant's just like a number, like 10, 11, whatever. Cool?
Okay.
Helps a little.
Yes.
Okay. All right, so here's the thing. I want to talk about these, okay? You know what ticks me off? My wife. Okay, let me explain, because that was kind of bad. My wife, it takes me off because she loves the red ones. How many of you, red, your favorite?
I love all of them.
You love all of them?
Yeah.
Okay, there's only one that is of the devil. There's only one color that's of the devil, and it is?
Yellow.
Yellow.
I know.
No, it's my favorite.
Orange is
Orange
good.
Orange is good.
No, I told you yellow.
Are you gonna say pink?
Yellow's my favorite.
Pink is my
Yellow.
favorite.
Orange is the worst.
No.
Yes,
I
I'm
was
just
just
telling
telling
you
right?
that.
I love orange.
Okay, so here's what I need from you, okay? I want to show you something here in just a second, but before you open them, Well, you're actually not going to be able to eat them. I'm going to have to use them for the other class. So I'm joking. I'm completely joking. But if you could just quickly, if you could get out the new notes just at the front, I'm going to start with the golden nugget. This is a double golden nugget.
Start with the golden nugget.
Why are you starting with the gold? Why are you changing the dynamic?
I know I shouldn't. I really shouldn't. But
Okay.
okay. So my wife one time decided that she was going to be selfish and eat all of the Starburst. So there's a 10. Each one has a 10-pack. Okay. So she opens it, and out of 10, we didn't do this ourselves. Okay, so that'd be kind of nerdy. But when we look at the amount of red, I know. But when we look at the amount of reds out of 10, what are the possible outcomes of the amount of reds within a Starburst packet?
12,
So it's 0,
1,
1, 2, yeah, you got it, right? 3, 4, 5, 6, 7, 8, I know, I hate that, 9, 10. All right, it's beautiful, all right? So question, what is the probability? So the probability is, there's 4 of them, right? So 0.25 to get ahead. How would I get, what would be the probability I would get 0 reds? 0.75, Chris, this is kind of what we were doing this today. 0.75 to the 10th. Great job, Chris. Yeah, good job. So Brianna and Chris got that. So 0.75 to the 10th. Because each one is independent of the next, okay?
Wait, where are we?
I think there's a blank space right below yours. You can put it right there. It's good. All right, so question, what's the probability of getting 10?
0.25 to 10.
0.25 to the 10th. I heard Chris and Shane roll. Someone else may have, but I heard them too. 0.25 to the 10th. Rockin'. All right, so those are easy. Now, you don't have to actually solve these. I'm going to show you why this can be very difficult. Because then if I go to 5, what makes it tricky to find the probability here?
You don't know which, you can't just use 0.25 minus 1 or 0.25.
Bingo. It's difficult, isn't it? Because how many combinations do we have for that to get 5 reds?
A lot.
Oh my word, there's a ton, and then you have to solve for them, and then you have to, there is a ton. So guess what we're going to do? We're going to do what we do in AP Stats when we don't know the answer. We're just going to put little question marks right now.
I don't get how we got to 10 or 0.
What's that? Over here?
Oh, we got 10 or 0.
Okay, so what's the probability, if I open this up right now, this first one, what's the probability this is going to be red? Oh Lord, please give me a red. Or the devil
orange?
color.
I
Who wants
would say
orange?
That's
I
orange.
do not like orange. I do not like orange. So the probability that would be a red would be 0.25, right? If I had a pack of 10, that would be 0.25 10 times. Does that make sense? So the first one, the probability of the first one's red is 0.25. The second one's 0.25. And we go to the 10th power and we multiply it 10 times by itself. The counter of that, though, is true. The probability that this one right here, my last one, will not be a red would be 0.75. And if I did that, it'd be 0.75 to the 10. Does that make sense? It is red. Okay. Very good. Okay. Does that make sense? Am I good? Am I good? Does that make sense there? But here's the kicker. We don't know what these are. Go ahead and eat. Hold up. Did you eat that?
She never opened it.
How did you get 2?
What's
You
the
left one
probability?
behind.
I did. Yeah, I gave it to you. I had leftovers. All right. So this over here in the middle, there's a lot of combinations that are here. Okay.
Yes.
Now, what we just talked about is this idea called a binomial distribution. Okay. Now, the reason why I'm going into the golden nugget first is I think it's going to help us in going forward. Now, here's the beauty of this. Put a line below this part right here. I just wanted this section. This was something that I used last year, but I don't want all the stuff below it. Just kind of X the stuff below it. But this stuff right here is really good. Okay, we're going to talk about the red starbursts. And go ahead, you can open yours, okay? You can open them there. Y'all are like ready to go there. Love it.
Yellow and red. Yellow and red.
I
Gross.
love it.
Oh my god, it's yellow and red.
Is it?
Yeah.
Do you want yellow and red?
I guess yellow and red.
You want to trade for orange?
Hey, you want a yellow?
We got trading going on. Look at this.
Does anybody have a pink for an
Do you want a
orange?
yellow for an orange?
Pink for an orange?
Ew, why would anyone trade red?
I know.
Yellow for an orange?
Hold up. No one likes orange.
No.
Orange is
Hey,
gross.
you just stole that from me.
No one likes orange.
She's forced trading me.
Hold up. Did you just trade a
Want a
yellow?
yellow?
Yeah.
Your grade's going down. Like, no way. Your grade's going down.
Do you wanna get?
All right, here we go.
Wait, does anyone want to trade a red for a pink? I'll trade you a red for a red.
Blue mountain yellow.
Bet. Okay.
Why would
Are we
trade
trading
red
right now?
for a red?
Okay,
This
so
red's better.
yes, go ahead, please. Yeah, go ahead. So here's what I want you to think about. Okay, the probability of
You can have one on.
Try it with the wrapper on.
Oh my gosh, what?
It goes away.
I used to do that when I was a kid. That's
Kristen. Don't do that. Don't succumb. Don't succumb to that. Okay. Wow. I don't even know what to say there.
Wait, open your mouth.
This is our team.
Why?
No, it's
You
all.
can't taste it.
All right. Here we go. Let's go. Binomial distributions. Let's talk about this. A binomial setting. Okay. All right. Here we go. Let's focus in. Okay. Although it's hard, I know. When we look at this, there's 4 things. In order for this to be a binomial distribution, there's 4 things that have to occur, okay? So I'm giving you the really important stuff right now, and I would start this and come back to it, okay? All right, you ready? Don't tell me you did it too. Y'all are seniors. Y'all are seniors. I would never do that. I can't do that. No. I don't succumb.
Do it.
Oh,
Good shame.
you don't taste it.
Exactly.
So it's
why?
really chewy. It's
Why?
really chewy.
Wait, let's try.
So don't waste time opening them anymore.
All right.
Whoa.
Oh, awful.
Definitely
It's really-
taste
It's
Yo,
not
what do you
good.
mean you can't taste this?
This is disgusting. You just ruined my red
I'm
one.
so upset. I'm upset at all you guys right now.
Okay, for real, like I gotta get going. All right. Bins. Okay, you gotta get this down. Now, we're gonna use the red starburst to understand, is this a binomial distribution? There's 4 things that have to occur, okay? Number 1, is it binary? Okay? So, again, you got the notes there. I've already done them for you. You just want to fill in the blanks. Each observation falls into one of just, someone raise their hand.
2.
How many would it be? Let's go Alex, I don't think I've called it. 2. 2 categories. Good. Nicely done. Okay? What would be the 2 that would be there? If I looked at a binomial, there's 2 different categories it could be in. Michael, do you know?
You could do like 0 or 1, or you could do like yes or no, or like true or false.
Yeah, actually, we call that, if it's a yes or it's a no, we call that success or failure. Okay? Success or failure. So success, in my instance, would be a red starburst or not a red starburst. Okay? All right, so this is important. When we look at this, right here, the probability that there will be a success or failure, this does not mean good. What do you mean by that, Coach? I could just as easily said, what is the probability that this starburst would be an orange starburst, right? And in my context, that would be a bad thing. But in this, that would be a success based upon my scenario. Am I making sense on that?
Yes.
I could also say, what's the probability that the basketball team will win the next whatever games, right? But I also could say, what is the probability they would lose? But in the context of the lost, even though that's bad, that would be a success percentage. Am I making sense on that?
Yep.
This happens all the time when you talk about Vegas or odds. It's kind of intriguing. So that's binary, 2 categories that are there. Independent, the end observations are all independent, meaning, someone raise their hand, tell me. Brianna?
One outcome does not affect the other.
Yeah, one does not affect the other. And I like what you said, one outcome does not affect the other. I like that. Nicely done. All right, that's number 2. So in order to be binary, there's 4 things. Bins. Binary, is it independent? N is the number. So there's a fixed number N of, yeah, it's kind of both. So outcomes and trials. I would put trials in there. That's the word, but I would also say outcomes could also be interpreted as that way too. So there's a fixed N of outcomes. Success percentage, the probability of success, P, is blank for each trial. Someone raise their hand if you think you kind of know. Is blank for each trial. P is like the probability, so ours was what? Ours was 0.25 for the context of the red starburst. So is blank,
Equal.
Success would be point.
yeah, Michael, say it again.
Equal.
Is equal for each trial, right? So it doesn't change. each starburst, kind of like Independence, but each starburst would have the same success percentage from one to the next. So I kind of gave you the golden nugget as we head into this chapter 6.3, and that's where we're going to be kind of going into there, okay? And that's why there's so many different outcomes. We have ways to solve this in an easier method, okay? All right, is everyone good on that?
You say, uh-huh.
If you're good, say uh-huh. That's right, that's right. All right, hey, I have 3 minutes. I wanted you to watch this video. I'm a huge basketball fan, and binomial distributions this is the most beautiful thing when I think about binomial distributions that I could bring. And we'll talk about this more. But this guy, so Memphis is in 2005. They're down by 2 with 6 seconds left. Louisville's up by 2, but this guy's coming up to the free throw line with 1 more free throw left, okay? And Alex, would you mind hitting the lights for me? So we could just see here. You're going to see Memphis has to win this game to go to the NCAA tournament. If they lose, they're out. They're out. They're done, okay? And this is what goes down. I want to see if you can get it here. Oh, no. Okay, there we go. He misses it. $2005. You know who that is? It's Coach Calipari from Kentucky now. There's Kentucky. So he's got what right now? How many threes or how many free throws has he hit? 3, yeah. So he has no time on the clock. How many of you be nervous as young right now? 3 free throws. What happens?
He makes them all in.
Misses them all? Makes them all?
He makes 2.
He makes only one.
He doesn't do it.
Did you hear the announcer, by the way? He said, let's do the math. They're down by 2. If he makes all 3 free throws, they win. Thank you. He was not in stats. I'll just tell you that right now. All right, here we go. The season's on the line, y'all. I mean, this is
That is so much I throw the ball the other direction.
This is the first one he makes.
all right. So before we goes into it, I want to just talk about that.
First of all.
So if oh man, well there we go.
Don't just play it.
We'll figure it out later.
Oh my
No, looking it up.
I'm researching.
I love it. I love it. What happens? Don't cheat. Don't cheat. We'll show you Thursday.
Oh
Have a
my
great day.
God.
Have a great day.
Honestly, I feel like I'm getting like 5 minutes.
You like a loser.
I'm not gonna miss it.
Ew, that was gross. First of all.
Hold up. Did Kristen come up with that?
Yes.
Kristen, that was the worst idea.
No, it tastes the same.
No, it does not.
It
It does.
It was like
Chrissy, I do that every time.
No.
That's awful.
How did you all find it out that you can use it?
Hey, that's gonna mess up your digestive system.
Yeah.
It doesn't.
It's like
How many
bagel.
times have you done that?
Try 20 now. Halloween rolled around.
She eats them like that all the time. Yes.
See, Jack. Hey, did that help at all?
I think so. If not, I'll come in like tomorrow or Thursday.